Hello, in this video we're going to continue studying cosets, only now we're actually going to look at an explicit example of a finite group and look at some cosets inside that finite group to get some idea how do you calculate the elements in a coset. As a reminder, given a group G and a subgroup H, that's a subset of G and some element little g, the coset generated by little g is this set. It's the set of all products, little g times little h, where h is in the subgroup. So it's a good reminder that it is a set. So as a first example, let G be the symmetric group on 4 numbers, the first 4 positive integers, and let H be this subgroup. Yeah, you do have to prove that this is in fact a subgroup. It turns out, well, any of these elements is order 2, and so it is its own inverse, so you're closed under inversion. And you can check that the product of this element and this element, any 2 of these elements, is the third. And so this actually is a group. The other way to check this is to take your rectangle and label it 1, 2, 3, 4, and you can check that the symmetries of the rectangle are exactly these permutations. So there's a shorter proof of that. Let's look at the cosets of H. So here's an example of a coset. I'm going to multiply on the left by the transposition 1, 2. By definition, this means for every element in H, I need to look at the product G times little h. So G times the identities here, G times this permutation, G times this permutation, and G times this permutation. So this is my coset. Of course, if I leave it in this format, it's kind of poor taste because clearly more work can be done. At the very least, that can 1, 2 times itself is the identity. But also, these are not disjoint cycles, so I should probably compute these products. Suppose I computed these products, then this is the result. This cycle turns out to be this one. Why? Because 1 goes to 3, then 3 goes to 1, which goes to 2, 2 goes to 4, and 4 must go back to 1 at that point. And there's a similar calculation here. So this is this coset. Similarly, I could ask, what is the coset 3, 4, H? Well, it's going to have the element 3, 4. It's going to have the element 3, 4, 1, 2, 3, 4. 3, 4, 1, 3, 2, 4. And 3, 4, 1, 4, 2, 3. You can calculate this. These 2 elements commute, and then the 3, 4s cancel. So I should get 1, 2 here. For this permutation, what happens? 1 goes to 3, which goes to 4. Oops, let me be careful there. 4 goes to 2. And 2 goes to 4, which goes to 3, so 2 goes to 3, and then 3 goes to 1. And for the other permutation, we see that 1 goes to 4, which goes to 3, so that should be 1 goes to 3. 3 goes to 2, and 2 goes to 4. So there's another example. But if you look at these 2 examples, they're actually the same, so that makes me feel kind of stupid, but this was on purpose, by the way. This is a fact we will prove in a later video, but it turns out, in this case, these 2 cosets were actually the same. And so sometimes it's good to note in advance when the coset was going to be the same so that we could have avoided this tedious calculation. Namely, we already had the 3, 4 here, and so that we'll see that that should have been a clue that this was going to be a waste of time. Although it's not a complete waste of time, it's meant for instructive purposes. The point of doing this is so that you learn so that you don't waste your own time. So I guess we should try a different example. How about multiplying by 1, 3? Yeah, I'm sorry I keep doing 2 cycles, but they're easier to calculate, so I'm going to stick with that. And you get 1, 3 times 1, 2 times 3, 4. 1, 3 times 1, 3 times 2, 4. And 1, 3 times 1, 4 times 2, 3. So this is going to be slightly, the first part and the third elements are going to be easy to calculate. What's this middle element going to be? It looks like 1 goes to 2, 2 goes to 3, and 3 goes to 4. The third element's the cycle 2, 4, and the fourth element, it looks like 1 goes to 4, 4 goes to 3, and 3 goes to 2. We see that this is not the same coset as the first one we got. So this is actually a different coset. So with respect to H, these 2 elements are related because they lie in the same coset. These 4 elements are all related because they all lie in the same cosets. But these 2 elements are not related because they lie in different cosets.